Hi everyone, I'm Bella. This video I will share with you BellaMaths KSSM Syllabus Form 4 Chapter 3. This chapter got two subtopics. I will share with you the first subtopic in this video. Let's start! KSSM Syllabus Form 4 Chapter 3 System of Equation. In BM, they call it System Persamaan. There got two subtopics in this chapter. I will discuss the first subtopic in this video. 3.1 System of Linear Equation in 3 Variables. There got 3 main points that you have to know in this subtopic, which is the characteristic, 3 types of solution, and the methods of solving the linear equation in 3 variables. Okay? Let us discuss what is the characteristic. The characteristic of system of linear equation in 3 variables has 3 variables and the higher power of each variable is 1. For example, x plus y plus z equals to 3. You can see that they've got 3 variables, which is x, y, and z. And their power is 1, okay? Not 2, not 3, okay? So another example, x plus 2y minus 3z equals to negative 15 and 2x minus 4y plus z equals to 14, okay? For your information, if it is 2 variables, it forms a line in a graph. When it comes to 3 variables, it becomes 3D and form a plane in a dimensional space. So there are 3 types of solution. The first one is one solution. Let me show you this. When in 2 variables, there got 2 lines. When these 2 lines meet at one point, which is the intersection point, that means one solution. They only meet at one point, okay? So when these 3 different planes meet on one point, that means one solution, okay? The second one is no solution. What it means by no solution? No solution in 2 variables means these 2 lines totally doesn't meet. When it comes to 3 variables, you can see that all the 3 planes doesn't meet at each other. Okay? Here are also the example of no solution. The last one is infinite solution. What it means by infinite solution? Okay, for 2 variables, the 2 lines meet on each other. Okay, so instead they meet on one point, the line intersect in a straight line. So when come to 3 variables, it also happen the same thing. All the 3 planes intersect in a straight line. So not only got one solution, all the point on the straight line here is the solution. Okay, here is also the example of infinite solution. The last part is the method used to solve the linear equation in 3 variables. There got 2 methods, which is elimination, which means by penghapusan, and the substitution, which means by in BM is penggantian. I will show these 2 methods in the example. Example 1. Solve the following system of linear equation in 3 variables by using elimination method. Okay, here are the 3 linear equations. So I will label the first linear equation as number 1, the second one as number 2, and the third one as number 3. For elimination method, you have to choose to eliminate one of the variable and left the another 2 variables. You can choose either to eliminate variable x or variable y or variable z. You will get the same answer. Okay? So now I will choose either 2 equations. I will choose equation 1 and equation 2. Okay, why I don't choose equation 2 and equation 3? Because here is 2x and here is 5x. It will be very hard to eliminate it. So I will choose this and this. So the equation 1 I can times 2 to get 2x. Okay, so the equation 1 I times 2. I will get 2x plus 2y plus 2z equals to minus 4. So this is my new equation, which I label as equation 4. So here is the equation 2, 2x minus 3y plus 4z equals to 14. So here is equation 2. Now I will minus equation 4 with equation 2. So 2x minus 2x, you will get 0. 2y minus 3y minus you will get positive. So you will get 5y. 2z minus 4z, you will get minus 2z equals to minus 4 minus 14, you will get minus 18. This is your new equation. I label it as equation 5. Okay? So now I choose equation 1 and equation 3. So as the same way as here, I will times the equation 1 with 5. So I will get 5x plus 5y plus 5z equals to minus 10. So this is my new equation. I label as equation 6. Okay? So I move down the equation 3. 5x plus 2y minus 3z equals to 10. So this is equation 3. So now I will minus equation 6 with equation 3. 5x minus 5x, you will get 0. 5y minus 2y, you will get 3y. 5z minus minus, you will get positive. So 5z plus 3z, you will get 8z equals to minus 10, you will get minus 20. Then this is your equation 7. Okay? So now I want to eliminate one of the variable of either y or z to get only the last variable. Okay? So now I will choose the variable z. Why I choose variable z? Because when this minus 2 times minus 4, then I will get 8, isn't it? Okay? So equation 5, I will times minus 4. We will get minus 20y plus 8z equals to 72. This is your new equation, which I label as equation 8. So now I move down the equation 7 here. 3y plus 8z equals to minus 20. This is your equation 7. Now I can minus equation 8 with equation 7. So you will get minus 20y minus 3y, you will get negative 23y equals to 72 minus 20, you will get 92. Okay, so your y will get minus 4. After you get your y value, you can substitute into either equation 5 or equation 7 to get your z value. Okay, let me choose equation 5. Okay, so 5y equals to minus 4 minus 2z equals to minus 18. So minus 2z equals to minus 18 plus 20. So here you will get is 2 minus 2z here. So z, your answer is minus 1. After you get your answer for y and z, then you can substitute in either equation here. Okay? So let me choose the equation 1 as equals to minus 2 minus y minus z, which is minus 2 minus y is minus 4. Z is minus 1, which is you will be getting the answer is 3. So you can make the conclusion x equals to 3, y equals to minus 4, z equals to minus 1. Example 2. Solve the following system of linear equation in 3 variables by using substitution method. For substitution method, you have to choose either one of the linear equation and express the one of the variable in terms of another 2. Okay? For example, you will choose to express variable x in terms of y and z, or variable z in terms of x and y. Okay, let me show you. I will label this is the equation 1, this is the second one, and this is the third one. Okay, now I choose to express x in terms of y and z. Okay, so for equation 2, I will express x in terms of negative 19 minus 5y plus 3z. Okay, this is my another new equation which I label as equation 4. Now I will substitute the equation 4 into either equation 1 and equation 3. Okay, let me start with equation 1 first. So substitute equation 2 into 1. So it will be look like 3 minus 19 minus 5y plus 3z minus 2y plus 4z equals to 12. Okay, now you will get negative 57 minus 15y plus 9z minus 2y plus 4z equals to 12. So you can rearrange it become negative 17y plus 13z equals to 69. So this is your new equation, which I label it as equation 5. So now I choose substitute equation 2 into equation 3. Okay, so 2x is minus 19 minus 5y plus 3z. Okay, plus 7y minus z equals to minus 15. So you times inside, you will get negative 38 minus 10y plus 6z plus 7y minus z equals to negative 15. So you rearrange it, you will get minus 3y plus 5z equals to 23, which is your new equation I label as equation 6. Okay? So now I have equation 5 and 6 with only variable y and z. So now I can rearrange either one of the linear equation. Let me choose to rearrange the equation 5. Okay? I make it become y in terms of z. Okay? Y equals to 69 minus 13z over negative 17. Okay? This is, I label it as 7. Okay? So now I can substitute y into this equation 6, which is negative 3, 69 minus 13z over negative 17 plus 5z equals to 23. Okay? So you rearrange it. I will times negative 17 to O. Okay? Negative 3, 69 minus plus 5z times negative 17 equals to 23 times negative 17. So you will get the answer is negative 207 plus 39z minus 85z equals to negative 391. So now here you will get is negative 46z equals to negative 184. So z is equals to 4. After you get your z value, you can substitute into this equation 7. So you can get the value y. 69 minus 13z is 4 over negative 17. So you will get your value y as negative 1. After you get your value z and value y, you can substitute in either one of the equation here to get your value x. X equals to negative 19 minus 5y plus 3z. So it's negative 19 minus 5y is negative 1 plus 3z is 4. So you will get your x value is negative 2. So in conclusion, x equals to minus 2, y equals to minus 1, z equals to 4. Example 3, solve the following system of linear equations. So this got two parts. Let's see the first part. Since the equation doesn't mention that you have to use elimination method or substitution method, so you can choose to use either way, okay? So the same way, I will label my first equation as 1, second equation as 2, the third equation as 3. For this question, I will choose to use elimination method to eliminate the variable x. So I will choose the equation 1, 2 times 2. So I can eliminate the 2x here. 2x minus 6y plus xz equals to 22. This is my equation 4. So now I move down my equation 2. 2x minus 6y plus xz equals to 14. This is my equation 2. Now, I want to minus the equation 4 with equation 2 to eliminate the variable x. But I found that 2x minus 2x, I get 0. Minus 6y, minus become positive, I also get 0. xz minus xz, I also get 0. So at the left hand side here, I get 0. But 22 minus 14, I get 8. This is impossible to say that 0 is equals to 8. So I can make the conclusion that since 0 is impossible equals to 8, so the system has no solution. Okay, so let's see the second part. The first step, I will do the same way. Label it as the first equation, second equation, and the third equation. So now I will choose to eliminate the variable y. Now I have to times my equation 1 with 2. So I can eliminate the variable y, 2y here. Okay, it will become 8x minus 2y plus 4z equals to minus 8. This is my equation 4. Now I move down my equation 2. 3x plus 2y plus z equals to 18. This is my equation 2. Now I can plus my equation 4 with 2. So I can get 11x plus 5z equals to 10. This is my equation 5. Now I want to move down my equation 3 and equation 1 to eliminate my variable y. 15x minus y plus 7z equals to 6. This is equation 3. 4x minus y plus 2z equals to minus 4. This is my equation 1. So I will use my equation 3 to minus equation 1. I will get 11x plus 9z equals to 10. I'm sorry, dear, 7 minus 2 is 5. Okay, so this is my equation 6. So at the end, you can see the equation 5 and equation 6. If you minus equation 5 with equation 6, 11x minus 11x, 5 minus 6, you will get 0. 5z minus 5z also get 0. So equals to 10 minus 10, you also get 0. So I can make the conclusion here. Since 0 is equal to 0, the system has infinity solution. Example 4, if xyz is equal to s4r is the solution for the linear equation system of this, find the value of t and r. Okay, so now I will substitute all the value of xyz into this equation. So my value of x is s. This is s. Value of y is 4. And value of z is r. This is 4. And this is s. Okay, now I rewrite the equation again. 3x plus 4 times 2 is 8 minus r equals to 9. I can rewrite it become 3s minus r equals to 1. This is my first equation. So the second equation, s minus 4t plus 2r equals to 2. This is my second equation. And then the third one is 12t minus 3r equals to 11. This is my third equation. Since the equation doesn't mention they have to use elimination or substitution method, so I can choose either way. Now I will choose to times my equation 2 with 3, so I can eliminate the t. Times 3, it will become 3s minus 12t plus 6r equals to 6, which is equation 4. Now I move down the equation 3 here, so it becomes 12t minus 3r equals to 11. This is equation 3. I will use my equation 4 plus my equation 3. Then I will get 3s minus 12t plus 12t, then you will get 0. 6r plus minus become minus, you will get 3r equals to 17. This is your fifth equation. Now I can minus my equation 5 with equation 1 to get my value r. I rewrite my equation 5 here. 3s plus 3r equals to 17. This is my equation 5. 3s minus r equals to 1. This is equation 1. So I minus my equation 5 with equation 1. I will get 4r equals to 16. So my r is 4. After I get my value r, I can substitute in either equation 1 or equation 2 to get my value s and t. Okay, so let me find the answer for s. 3s minus r, which is equals to 4, equals to 1. 3s equals to 1 plus 4. S equals to 5 over 3. Now I want to substitute the value r into equation 3 to find the value t. 12t minus 3, r is 4, equals to 11. 12t equals to 11 plus 12. 4 times 3 equals to 12. T equals to 23 over 12. So in conclusion, they want to find the value for t and r. So the t is 23 over 12. R is equals to 4. Example 5. What is the value of A that makes the following system? Have no solution, have only one solution, and infinite solution. Okay? Now, I will use the normal way, which is I will label all these three equations as the first equation, the second equation, and the third equation. Now I will choose to use the elimination method to solve this equation. I will choose the equation 1 times 3. Then I will get 3x plus 6y minus 9z equals to 12. This is my equation 4. Now I move down the equation 2. 3x minus y plus 5z equals to 2. This is my equation 2. Now I use my elimination method to minus the equation 4 with 2. Then I will get 6y minus become positive. I will get 7y minus 9z minus 5z again. I will get minus 14z equals to 12 minus 2. I will get 10. This is my equation 5. Then I will choose my equation 1 to times 4, so I can eliminate the variable x with equation 3. Equation 1 times 4. I will get 4x plus 8y minus 12z equals to 16. This is my equation 6. I move down my equation 3. 4x plus y plus a squared minus 14z equals to a plus 2. This is my equation 3. Now I will use my equation 6 to minus equation 3. 6 minus 3. 4x minus 4x becomes 0. 8y minus y becomes 7y minus 12z minus a squared z minus become plus 14 z equals to 16 minus a plus 2. I rearrange it. I will get 7y, 12z plus 14z, I will get 2z minus a squared z equals to 16 minus 2, I will get 14 minus 8. This is my equation 8. Now I will minus these two equations so I can eliminate the variable y. Okay? So 7y minus 7y, I will get 0. My equation 5 minus equation 8, 7y minus 7y, I will get 0. So minus 14z minus 2z plus a squared z equals to 10 minus 14 minus 8. Minus 14z minus 2z, I will get minus 16z plus a squared z equals to a minus 4. I rearrange it, I will get a squared minus 16 z equals to a minus 4. So I will know the z value is a minus 4 over a squared minus 16. Okay, I will stop at here first, then I will back to my question. What is the value of a if the system has no solution? Okay, for your information, when there is no solution, it is also mean undefined. When a fraction is undefined, that means the denominator is equals to 0. Then we will say the fraction is undefined. So I can say that a squared minus 16 is equals to 0 because we want it to become undefined, so it is no solution. So I can get a squared equals to 16, a equals to plus minus 4. Okay? From the previous example, we know that left-hand side cannot be equals to right-hand side when the linear equation has no solution. So now from here, since we say that a squared minus 60 is equals to 0, here is equals to 0 already. So we can say that a minus 4 must not be 0. So I can make it become a non-solution. So a minus 4 cannot be 0 since here already is a 0. So a cannot be 4. So here a is plus minus 4, but here say a cannot be 4. So I can make the conclusion that a is only can be minus 4. Let's see the part B. What is the value of a when there have one solution? When a fraction have a solution, that means the denominator cannot be 0. So I can say that a squared minus 16 cannot be 0. A squared cannot be 16. A cannot be plus minus 4. So this is the answer. Then let's see the last part, an infinite solution. What is the value of a when we can get an infinite solution? Okay, let's see. We copy this to here. A squared minus 16 z equals to a minus 4. From the previous example, we know that for an infinite solution to be exist, 0 is equals to 0. So I can say that this is equals to 0. This is equals to 0 also. So I can write it a squared minus 16 equals to 0. A equals to plus minus 4. And here, a minus 4 equals to 0. A equals to 4. But my final answer is a equals to 4. Why I didn't include the minus 4? Let's say I put minus 4 here. Minus 4, you will get minus 8 here. But minus 4 squared, you will get 16 at here. 16 minus 16, then you will get 0 at here. 0 is impossible equal with minus 8. So it will become no solution. Okay, so I only can accept the answer A equal to 4. Example 6, in a football match, the prizes for winner 1 game, draw 1 game and lose 1 game were 3,000, 2,000 and 1,000 respectively. A team has played a total of 10 games and has won a total prize of 23,000. The number of games won and draw is 4 times the number of losing games. Okay, our legs x equals to win 1 game and y equals to draw 1 game. And the last one, z equals to lose 1 game. So now I will use the information from the equation to make 3 linear equations with 3 variables, okay? So from the first information, a team has played a total of 10 games. The equation says that they played 10 games. That means x plus y plus z equals to 10. This is my first equation. And he said has won a total prize of 23,000. That means 3,000 times x plus 2,000 plus times y plus 1,000 times z equals to 23,000. So now I can simplify this equation by this way. Okay, so it's 3x plus y plus z equals to 23. This is my second equation. Now, the last information, the number of games won and draw is 4 times the number of losing game. So, the number of games won is x and draw is y is 4 times the number of losing game. So, it's equals to 4z. So, I rearrange this, become x plus y minus 4z equals to 0. This is my third equation. After I getting my 3 equations, then you can use either elimination way or substitution way to solve it. Okay? So now I will choose the equation 1 and equation 3. Why? Because I see this is x, this is x, this is y, this is y. So I can direct get my z value. Okay, I will use my equation 1 minus my equation 3. So x minus x you get 0, y minus y you get 0, z minus minus you will get positive. So z plus 4z you will get 5z equals to 10 plus 0 you will get 10. So z is equals to 2. Now I will choose the equation 3 and 2. So I will times the equation 3 with 3. And I will get 3x plus 3y minus 12z equals to 0. I move down my equation to 3x plus y plus z equals to 23. This is my equation 4. Then this is my equation 2 that I moved out. Now I can minus my equation 4 with equation 2. 3x minus 3x you will get 0. 3y minus y you will get 2y. Minus 12z minus z you will get minus 13z. And 0 minus 23 you will get minus 23. Now you can substitute the value z that you get from here into here to get your value y. So 2y equals to minus 23 plus 13z, which is minus 23 plus 13 times 2. You will get your 2y is equals to, I find some mistake here. You see, here is 2y. Okay, I forgot the 2 here. So here got another one, 2. 3y minus 2y is y only. Okay, so y you will get your answer as 3. After you get your z value and y value, then you can easily get your x value. X equals to 10 minus y minus z, which is 10 minus 3 minus 2. You will get 5. For this subtopic, I will stop here. If you need to know, you can use the link below to download it. Okay? If you found my video is helpful, do remember like, share and subscribe my YouTube channel. See you in the next video. Bye!